show how to process the data from viruses that are in the paper. And here I will show how to detect the nanobody labeling to the SARS-CoV-2 virus-like particles. Again, you import the data, and this comes from here, from the VLPs. And here I have a difference, so I have delta and beta variant of the spike, and then I have two nanobodies that are binding either exclusively delta, so FU2 is the delta nanobody, and EBD2 is a universal one that will bind both of them. So again, open. I go to the peak analysis. And here in the peak analysis, what you can do, you can again go here. Yeah, I would start again with binning everything together. And here I will go again detect by channel 1. In this case, channel 1 is GFP, which is within the viral particles. And channel 2 would be the fluorescence of the nanobody. So here, again, we can start, let's say, from delta FU2. So delta FU2. Yeah, and this is one peculiar sample. So in this case, I had here some viral particles that were without spike protein, and then two types of binding actually. So this one over here had the most binding nanobodies, and this one had less. Why this happened, I don't know, but I like to show this example because it also shows that this method can distinguish heterogeneities. And it's also visible over here that you have this one population, which most likely corresponds to this one, and this one corresponds to this one. And why there were two types of binding, I have no idea. Anyway, then when you go to, for example, beta FU2, which shouldn't bind at all, here you see only one population which is kinda right shifted. And then when you go to, let's say, this is delta plus EBD2. It is right shifted, and here you have some, again, particles that have no binding, and one big population over here that has binding. And when you go to beta EBD2, I will again show, so this one comes from non-binding particles, and this one comes from binding particles. So it is a good idea here. What I will implement next, I will implement the possibility to correct for the background, because when you do this experiment, you just mix you just mix virus-like particles with nanobodies, and then of course you have some considerable noise from nanobodies that still stay in the solution. And in order to compare between all of them, I have to normalize to this nanobody background, and that will be in the next iteration of this program that will be released soon, where you can select which formula to use and whether you want to do this background correction or not. But for now, you have this. My favorite is this one. with a couple of populations. And that's what the program can do.